This video will stand as a submission for two projects for an advanced computer graphics course, which I'm currently taking, but also as a log for myself as a record of previous computer graphics assignments, which I have completed. For this assignment, this was about silhouette edge and silhouette extrusion detection. These techniques are commonly used in shadow volume rendering, but for this assignment, we were really asked to undertake that. We were just asked to do a couple other things with them. And a big portion of this assignment involved learning about geometry shaders and how those all work. Within Vulkan, geometry shaders are not supported by default or not required by GPU manufacturers to support these types of shaders. So these are features that need to be enabled within the device instance that is created for Vulkan, and also the corresponding queries are needed in order to ensure that a device does support these features. But anyway, once you have that enabled, you can create a pipeline for a graphics pipeline with geometry shaders as part of them, and that is what I used for a lot of this assignment. So to start with, the first thing that I wanted to try and do was to just learn about geometry shaders. So we're going to start with talk about this little airplane model. This is a light source, and we will get to that in a few minutes. But the best way that I found to try and work on this was to start working or to look into the normals on each object. Normals are pretty important to know about, and where they actually end up are and can be a source of a lot of headaches, especially when you're working on lighting calculations. I know they've been a pain in my in my back a couple times. So I wanted to create a way of visualizing them, and a very common way of doing that is using a geometry shader. So all of the objects within this framework, I'm working on the same, we'll call it a rendering engine in the back, but it's more just like a couple classes that are super helpful to me to make this go along easier. All of these renderable object meshes, they all inherit from the same class. So if I manage to implement something in the base class, that means that all of them will be able to have this. So I wanted to implement a geometry shader pipeline that all objects could share, especially because attaching a pipeline is one of the most expensive operations you can do in Vulkan. So implementing this in a way that all objects could share it would increase performance a lot, theoretically. In my experience so far with working with this, it's not made that big of a difference, but it's nice to have nonetheless. So for this, if you hit N, it will draw the normals from every vertex, and this is a very low polygon mesh for this reason, so that it's a lot easier to follow. And you can see that these normals are in fact correct, which is great. And that's why the lighting does look correct in terms of where this light is. But another part of the assignment was to try to do silhouette edge detection. So where the edge of the model is in reference to the background and where the camera is. And I honestly didn't think about that too much when I was working on this, because I was more worried about the extrusion part of this. But I did implement a shader which does that kind of as a we'll call it a debug way of debugging the actual silhouette extrusion I was working on. But if I turn these normals off, and I'll go ahead and do edge highlights, which is with it is with B, you can see the green line are the parts or the edges of the model which are actually facing the light. And these, once we get to the edge extrusion, as you saw me, I hit the wrong key there for a moment. These are the edges that are going to be involved in the generation of the lines that are created, or at least the vertices that are part of these edges are the ones that are the parents of lines that are generated. But yeah, this actually, it is kind of funny that if we go underneath the model here, you can see that the edges on the bottom here still quote unquote face the light. There's a little bit interesting one here. I'm not quite sure why that one was showing up, but that kind of confused me at first. But it's a strange thing where implicitly I assumed that since the top of the model here was in between the wheels and the light, that they shouldn't be lighting up, but that was just a silly thing on me. But yeah, this is working correctly in that it does highlight the parts of this model which are facing the light. And there are a couple oddities, and I think that is in with how the camera is moving. And this version of I've been calling this framework Starlight that I'm working with. In this version of it, I haven't fixed some of the camera normals. Since the completion of this project, I have fixed it, but that's a tangent for another time. So I'll go ahead and turn that off, and we can look at the extrusion part of this. And so using all those vertices that we just saw before, that are part of those edges that were highlighted, if I turn the highlighting back on, those edges are the ones that are going to be involved in with the line generation. Although the edges I was looking for are the ones on the outside of the model, so it's not all of them that are involved. Like if I move the camera down here, there are a couple other vertices like here, and it looks like that one might be highlighted, but there's a couple of vertices that aren't highlighted by the outline, just because those aren't the only ones that are considered. All of the vertices on the model are considered, not just the ones on the silhouette edge. But it is important to consider all of them, just because those are the ones that are, these lines will be the outline of this sort of silhouette. But yeah, this does update from the light's point of view. And they do extend a long way, and it's simply just like a geometry shader, where it looks, and if they hit that condition for being part of the silhouette edge, it extrudes a line. And yeah, the normals too and the actual edge part are also done with a geometry shader. And these are actually pretty cool, because in Vulkan as well, geometry shaders are able to write, I believe they're able to write to other attachments, which other shaders are not capable of doing. So that's pretty useful if you have to write to multiple different types of attachments and whatnot all in one render pass. So that means that you don't have to do a couple extra passes in order to make this possible. But anyway, that is the end of this demo. Thank you for watching.